Hello, welcome back to CIS 165. My name is Alex Louie. I'm going to go over some material for week 4. First, I'm going to go over some stuff based on comments. When you comment your code, give you a couple of different ways to comment your code. Then I'm going to explain to you a little bit more about the main function. The program structure, just going to show you how programs work in terms of identifiers and what you could and you can't use when you start declaring variables. I'm also going to go over something called typedef, which allows you to declare your own variable names and assign your own variable names with a base type, the base types that you've learned previously in these lectures. Today I also want to go over input and output, how to read from input from the keyboard and also write out to the console. Then I will go over some manipulators when dealing with output so that you can put some spacing and precision around your output. Give you a little bit of style guidelines on how to write your C++ code to your source so that you have the proper indentation, proper ways to declare variables, and proper ways to structure your program. And then finally, I'm going to go over some fundamentals in terms of input and output with file streams, how to write to a file, and how to read from a file. And of course, I'll go over a program which does this so that we put everything into full circle. The first thing I want to do is just go over real quick how to comment your code. You comment your code by putting 2 forward slashes. It's right by the key that has a question mark on your keyboard. You type it in twice, and then you can write whatever comment that you want. So I can say name, and that's my name. And I can do // and course, and I say CIS 165, and then I can just put the date. Today is the 19th. So once I run this, I go to execute and then compile. Once I compile, then I can go to compile and run. And nothing's going to show up because I haven't written anything to output. I haven't done anything in the program. What's going to happen is, because this is a comment, the compiler is going to totally ignore these lines. For the compiler, anything with a // means that it's just a comment and it could ignore it. Another way to write a comment is by doing a / and a star and then putting in whatever you want. This program will read in 2 numbers. It will also be for an assignment. This is my open comment, and then I close it by doing star and then /. The star is Shift-8, and then the / is the little question mark, the keyboard with the little question mark. This is my preferred method of commenting code because I don't have to keep writing // to any line that I want to comment. If I wanted to write a little bit of a paragraph, I can just write it in between these 2 comment lines. And these are 2 ways that you can write comments on your code. The next thing I want to go over is the function void main, or specifically in this one, it's int main. This is the main point of entry of your program whenever your program runs. Whenever your program runs, it's always going to look and start execution at this main function. You're going to put in your source code over here, and you're always going to leave these 2 lines without deleting them. It's very important because if you don't leave this line in here, then what's going to happen is the console window won't stay open. So let's comment this line out. If I do that and I do execute, compile, and run, see how that black window just popped up and closed again. If I uncomment this line and then I execute, compile, and run, then my window stays open. This is important because when we're reading and writing output, you're gonna need this console window up so that you can write in your stuff, you write in your input and your output. The program ends when the point of execution is at this point. We return a variable called exit success. This exit success variable is really an integer. I'll explain that more as the classes go on, but you basically either return a value based on the return type of the function. This main is called a function. It's the main function of your program. The return type is integer. This is returning, this value of exit success is an integer. So it would be either a 1 or a 0. I'm not really sure exactly what value it is. I think it is a 1 because in C++, 1 means true and then 0 means false, which is still, obviously, it's still an integer. That's what this line does. So you have to return a integer to this main function. The important thing here to realize is that no matter what, you have to realize that anytime you write your source code, it's got to be in between the open statement and the close statement, but also before your system code line, so that you can write in your code in here and are assured that it's going to execute. Now, the program structure goes like this. You usually have a main. You have your main, and this always shows up, and you need this main function so that you can program. Okay, but then inside your program, you're going to have some keywords that you can't use. For example, you really can't use anything that defines a variable. So if you have, for example, an int, okay, you can't use these words as a variable. So if I do int, okay, that's not allowed. Okay, if I do, and I've gone over this on previous lectures, so if I'm declaring a char, I have to, if I want to name a variable called, letter, that's okay. But this variable name, which are defined by you, cannot be another keyword, and that's very important. Okay, let me pause for a second. Let me resume. The other thing you've noticed is when you're writing code and you saw your first program assignment is that every line of code has to end with a semicolon. Every line of program has to end with a semicolon. If I was declaring a variable int b, it has to end with a semicolon. What happens if I don't end with a semicolon, then, and I try to compile this, it's going to give me a compilation error. Okay, it's going to say B does not name a type. This, because of this, okay, even though it points the error over here, the compiler sometimes is a little tricky to figure out, because it's going to say, well, I try to interpret this line, but I couldn't. So the error occurs on this line. It's really, you have to really keep doing it so that you realize what the compiler is trying to point at. It's not very intuitive. It should really point to this line, but it's not, right? So if I do a compilation again, it's pointing to this line. You're like, what's wrong with this line? There's nothing wrong with this line. It's the line before it. A lot of the things that you're going to see in DevShed C++ is that when you compile a program, it's basically always going to give you the error at the line after the error, which is not very intuitive. But as you program and start coding yourself, you'll realize this more and more, and you'll be able to pick up these errors. So this is what's known as a syntax error, because my syntax is incorrect. So for me to fix that, I would do semicolon, and I can compile, and that's okay. So you have to remember that every line ends with a semicolon. Let's talk about variables. Variables must be declared always before they can be used. And when I talked about, and you saw in previous slides, previous lectures, the PowerPoints, is that every variable is a location in memory. So if I do int number 1, that means that right now there is a location in memory called number 1 of integer data type. And if you look at the book, each data type has a size. Integer is 4 bytes. If I was to declare a char, I can make a character string array, and this means that it's going to be 20 bytes. If I declare a float, floats are, I think they are 2 bytes, if I'm not mistaken. And there may be 4, but now this floating data type represents any type of floating point numbers. Numbers like 2.3, 5, 6.8. Integers then represent numbers that are whole. 2, 3, 7. Double represents numbers that are also floating point, but you have a lot more space with a double. With float, you don't have that much space in terms of storage. I can use double to store bigger numbers, whereas with price, I can't use large, very, very large numbers. With integers also, there is a limitation as to what you can use as a minimum number and then as a maximum number. So the maximum number may be something along the lines of 32 million or 1.7 million, something along those lines. Whatever number fits into 4 bytes. And here, what I just declared is something called a character array. So this character array, that means that I've made 20 allocations, 20 boxes of 1 byte fields. And to put that more in terms of, put more intuitively, I'll open up Word and create a diagram. This basically means is that, let me do that. Actually, let's do a table better. So I'm going to do a table. That looks like that. I'm going to shorten this to 10 so that you can follow. So this character array of type char, okay, and I can do something like that, means that I've allocated 10 spaces. Each of these spaces is 1 byte long. So 1 byte, 1 byte, 1 byte. And then I can store a character A, B, L, and then also the number 3 as a character. You have to be careful with your data types because there is a difference between the character 3 and the integer value 3. It all depends on your data type. So for example, this number 3, if I declare it as an int, in this I'm declared number 1 as an int, and I assign it a value of 3, then it's considered a numerical value. But if I decide to put a 3 character here, it's not going to treat it as a numerical value because the data type, the underlying data type is char, as you see here. And your keyboard has different ASCII codes for each key. So for example, the 3 ASCII code will have a numeric value, an underlying numeric value, which is not the actual 3 that we are dealing with in terms of an integer, because everything on your keyboard is ASCII, obviously, and the char is specifically for that, for any input that's a string input, which is ASCII input on your keyboard. Each keystroke or each key size is 1 byte, and if you're asking the user to enter input, then you declare a char character array with enough space so that the user can enter in the characters that you are expecting. Okay. Now, with each variable, I can assign it a value at declaration time, or I can assign it a value after declaration. So This means that if I do that, that means I'm assigning the value of 3 to my variable number 1 at declaration time. But if I do something like this, semicolon, I'm assigning the variable 200 point, I'm assigning the value 200.38 to my variable price 2 after declaration. I can do it both ways. The preferred way is, doesn't really matter. What you should always do is when you do declare your variables, always initialize them. So for example, I would say I would initialize this to 0, and then I would initialize this to 0.0, so that I have a starting value. What happens sometimes in C++ is that in memory, you have to clear it out because there may be other garbage lying around in memory, and if you don't initialize your values and you're not using this variable until later on and you try and using it before, it might print out something that you're not expecting. So trust me when I tell you that you should initialize your variables first in declaration. You can also declare variables followed by comma. So if I had multiple variables that I was going to declare as an integer, then I can say number 1, number 2, number 3. Okay, sorry about that. And now I've declared 3 integer variables with the names number 1, number 2, and number 3. And I can also initialize these variables all in one line. And that's okay. If, just to give you a point, to prove my point, I can just say compile, and that compiles fine. The status is done. Okay. The important thing also to remember is that each variable, each data type has a storage limit. Integers have a storage limit, char has a storage limit, float has a storage limit, and double has a storage limit. What do I mean by storage limit? It means that you can fit only a limited amount of size of a value into any variable that is of data type double or float or char or int. The maximum amount of characters that I can fit into this variable is 10 because I've only allocated 10 bytes for my char variable called make. If I wanted to increase it, I can. I can say initially I want to declare it as 50. But the problem is now is that I could only store data that's of char type, anything that is a character. Okay, and the character is denoted by a single quote and then the actual character. Same thing with int. Int, I can only store, and if you go on Google or you can go in the book, it tells you the maximum amount of number that you can store in an integer type from negative to positive. And then you also have the unsigned value that you can fit on an integer data type variable. And what I mean by unsigned, it means that with numbers you have negatives and positives. But sometimes you may say, my program doesn't really need negative numbers, I only need positive. But you still have a limitation. You take all those negative numbers that you had initially, right, from negative 1 to negative 5 million. So you push it up, your limitation is a little bit more for your positive numbers. So you can only store from 0 to 1 trillion or something like that. I'm not exactly sure what the max is. But if you go on your book, it's going to show you that for an integer data type, you have limitations on max numbers, minimum numbers, and same thing for double. It's still large. You still don't have to worry about going over it, at least not for this class. But it's something to take in consideration that when you do use your data types, you don't have free space forever. It's not like when you store things in the cloud and you think that you have this infinite amount of space. That's not necessarily true. Okay, even with emails, I use emails as an example. Emails, you still have a limitation, right? If you log on into Gmail or any type of email client, it's going to give you the max amount of size of emails that you can have. Mostly it's pretty big. I mean, it's about 50 gigs or 100 gigs of email data. Same concept applies here with your data types. You have data types that have a limitation of numbers that you can fit into the variable. And if you go over that limitation, then your program is going to have a runtime error, meaning that when you run the program at runtime, it'll compile, but at runtime, it'll crash. So let me give you an example of that. If I do number 1, and I'm going to do some huge number like that, right? That number is definitely cannot fit into an integer data type. So as you see, it's giving me a warning, but it's compiling, it's allowing me to compile. Even though it gave me a warning, it says integer constant is too large for its type. That's just a warning though, it's not an error. It's still letting me run. And when I execute, compile, and run, let me try this bigger number. It's supposed to crash. Usually what it'll do is it's going to crash. So if I do number 1 plus number 2, if it doesn't crash, it's going to give you an unexpected result. Watch this. Compile and run. So it gave me a 9 as a result. Now I haven't taught you this yet, which we're going to go over in the next few minutes. But this is a command used to write output to this console window. So basically what it tried to do is it added number 1 and number 2, and it did 9 plus, but it totally ignored this number, which is not the correct result that you were expecting, right? Okay, so let me take this out. Okay. Now, with data types, you can also declare your own data type, but you must use a underlying base data type. I compare it to something called a synonym, right? In the English language, you have a synonym for certain words. You can have synonyms for different data types. For example, usually when you declare your data type, it's got to be outside the main function. You can do it inside, but in style rules, usually we do it outside. And what you do is you say typedef, and then you say double. And this is going to be the name of your new data type that you're creating. Now, for example, instead of me saying, and let me just do this, instead of me saying double price 2, I can say money price 2 is equal to 0.0. And if you look closely, money is underlying data type is still a double, because you must put in your data type so that compiler knows what the underlying data type is. But now I can use money throughout my program, and I can say price 3, 5.5, and I can compile this, and then I can run, and it will absolutely give me no error, because what the compiler sees is that money is your new data type that you invented, but the underlying data type, because of this typedef keyword, is double. And you can define anything that you want as long as you have an underlying data type. So if I do typedef int constant number, or I can just say integer, right? Then I can say integer variable integer, or integer variable equal to 7. What I've done here is I used my integer data type that I created, and then I created my own variable, right, called integer var, and this is now considered an integer data type, which is the underlying data type is int. These are very useful when you're writing your program because you can identify certain things or give synonyms to certain things or certain variables that you know are going to be of certain data type. So for example, we use a data type called money because if you were running a program based on money, then we know that the data type of money, the underlying data type, is going to be a double. A lot of people argue that this allows for more readable code. I really don't condone it, and I don't really use it in the field, but I do have to teach it to you because obviously you have to learn what a typedef is. And we'll learn later how to declare typedef arrays, which do come in handy sometimes. But again, it's up to your discretion of how you want to code your program. You don't have to you're not forced to use typedefs. Sometimes it does look nice, but other times it could be a nightmare because you could have a million of these here, and then obviously your code is going to be a disaster, right? For bigger programs, you just might as well just go with the underlying data type and just use it, not to add any overhead on your source code. That's my advice on this. So let's talk about output. And then I can leave that. And as I showed you previously, let me just do something here. We'll use D price for double, F for float, C for char, and I for 1. And what I'm doing here is I'm just putting the data type that it starts with as a prefix and then an underscore. That's usually the way I like to code. Try and get used to this, because when you start writing your 100-line programs, and if we have one standard, one format, then I'll know what data type it is, and you'll know what data type it is as you go into your code. So imagine having about 500 lines of code. If everything's prefixed with its data type, you don't have to scroll all the way up to see the data type of your variable that you're trying to do. For example, let's say I'm writing a lot of code here, and then I see something like I number plus D number, right? Then I know that you're trying to add an integer to a double, okay? Whereas if you just did, let's do that, right? If you just did that, then I'd have to see, okay, number and number 2, have to scroll all the way up, see your data types, right? Have to look for your data types under your variable declarations, and then I'll see that number 1, number 2, whatever their data type is. Try and get into the practice of doing that, trying to prefix your variables with their data type, the appropriate data type, so that you know where they are. Now, this library here, oh, that's my fiber. Sorry about that. Let me just log off this. Start task manager. Kosie's my daughter, by the way. She's got a little bit of a fever, so my friend is worried. Okay. The compiler sees this pound hash mark as a line of source code that it needs to replace with more code. What it's going to do is it's going to compile this code, and then the linker, and I'm sorry, the compiler itself will say that it's a library that's being pointed to. This particular case is IOStream. Includes other routines that I can use, and one of those routines is used so I can print out to the console. what I used before is something called cout. Basically, it's all lowercase, and you prefix it with C and then out. It's just like that. And then you need to use this cout with another operator called an insertion operator, which is a less than sign. And then after you do that, then you can tie this insertion operator with the appropriate operand, which we call in C++ terms, but it's basically just going to be a variable or some type of literal. Variable would be I integer var. What's happening here is the compiler is going to look at this cout, and then it's going to say, okay, I know that you're pointing me to write something out to output, but I need to see what you want me to write out to output. The way it sees it is that you have to include an insertion operator with the less than sign, and then you'll have the variable after that you want to write out. This will write out 7 to the screen because the value of this I integer var is 7. And if I compile this, compile and run, then you'll see the number 7 here. Okay, and then we'll get rid of this in a little bit to indent this line over to the next one, and I'll show you that in a little bit. This is a variable output. I can also output a literal, a string literal, and I can do something along the lines of, now I need another insertion operator, less than, and then I can say hello world, right? And what happens now is it's going to pair up each insertion operator to what it's going to print out. This one goes with this, and then this one goes with that. And then as I execute, compile and run, it's going to say 7 hello world. Okay, let me pause for a second. Okay, we're back. As I was saying before, with the cout, you can write out to the console screen using the cout keyword, and then you also need the insertion operator so that you can pair up what you actually want to print out. Here I'm printing out a variable, and here I'm printing out something called a string literal. You can also print out a number literal, and what I mean by a number literal is I can print out 7, do that, and then project execute. I'm sorry, I can close this, do compile and run, and then you see hello world, and then 7, and then obviously the value of 7. Now you notice something interesting here is that even though I pressed enter and wrote the 7 on the next line, it didn't do it on the actual console. I'm going to show you how to manipulate your output using some special keywords that you can use with the cout operator. Because the computer, the compiler is a little stupid. It doesn't know until you tell it to do something to actually do it. And in this particular case, it says I'm just using the cout to print out to console. I don't know if you press enter that you want to write it out on the next line. You actually have to tell the compiler to write it out on the next line. And the way to do that is you can say, you still need an insertion operator, so you say less than, and then you do something called end L. The end L will place a return character so that the next printout will be on the next line. So if I do that, compile and run, so you see 7 hello world, and then the 7, which is the number literal that I printed out. The other thing that I may want to do is, these are too close together. So what I can do is I can do a space in here, save that, and this way it looks a little bit nicer. And then now you have 7 and hello world. Now, how do I want to get rid of this press any key to continue and have it go on the next line, because it kind of scrunches up my output on this line. So usually what I always do is then on my last line that I'm going to print out, I can do another end L, save that, and then compile and run. And there we go. Now it's a little bit neater, right? Now you have 7 space hello world 7 and then space return, and then now you have the press any key to continue. You cannot get rid of this press any key to continue. So this is going to always be on your program when you run it. Again, I stress the fact that this is a number literal. It's called a numeric literal. This is called a string literal, and this is simply called a variable. Anything that you use cout and the insertion operator has to be paired up with whatever you're going to print out, even if it's something that manipulates the output. The cool thing about this is that you can also do math calculations right on the cout statement. If I wanted to do 60 plus 5, it's going to calculate it on the fly. So this should print out 65. So I save that, compile and run, and it'll do 65. And I can also do 65, 6 plus 5 divided by 3. Okay, and then I execute, compile and run. And it's going to give me the result. Now notice how if I do 60 plus 5, so I do 65 divided by 3, it should be 21.666. What the computer sees is that because I didn't put any decimal points on this, it treats it as an integer literal. And with integer literals, it's never going to give you a remainder. If I wanted a remainder, I would have to say 3.0, 5.0, 60.0. And by putting in the actual floating point, then I'm making it now a numeric literal, which is of double data type. And the compiler will say, oh, okay, so you want now a result that is actually of double data type. So if I do that, then it's going to give me the 21.66667. Okay, and there's also ways to manipulate the actual output with decimal points, in which we'll go over later in the course. Okay, so that's basically it for cout. And again, you can print out your variable, a string literal, or numeric literal, or you can even do a result of a mathematical equation. You can even do a numeric literal plus a variable. What this will do is it's going to add 70, and then what's the value of I integer var, which is 7. So I save that. So it should print out 7 hello world, then 77, and then this 20, 26 or 21 point something. So if I do that, so see that 77. Let me mark that so you can see it more clearly. That's 77. So you can intermix this all together. Okay. So that's that. Please review your cout, the lecture on cout, and you can play with this a little bit more. Now let me go over cin. And cin is the opposite of cout. As you're printing out output to the world, you may want to read input from the world. And with input, it's a little bit different because you can only pair up the operator with one type of operand, which is a variable. What you do is now we can start creating some real cool programs because we can read input from the user. Basically, what I'm going to do is I'm going to prompt the user to enter a number. And the first thing I'm going to do is I'm going to do cout, please enter a number. And then I'm going to put an inline. At this point, when I compile and run my application, it's going to say please enter a number, new line, and then now I have that. Now I want to prompt the user to actually enter something, and that's very simple. You do something called cin. Cin is a stream which allows for reading input from the user, and from the user or from any type of entity, because it doesn't necessarily have to come from the keyboard, it can come from anywhere. So what I'll do now is I will use something called an extraction operator, which is a greater than, and this is where it gets a lot different from cout, because cout, again, you can print out anything to the world, but for cin you got to be a little more specific, and it's a little more tight because you can only read into a variable. If I do I integer var, okay, and I run this at this point, nothing's really going to happen except that it's going to blink for me to enter something. It's going to wait for me to do something. So if I do compile and run, and then I enter a number, right, it's going to ask me, please enter a number. Now it's blinking for me to do something. So if I enter 6, the way it knows that I'm done is that if I press enter. So if I press enter, then it's going to say, okay, we're pretty much done. You entered something, and now I can continue execution. So what happens with cin is that it pauses execution at that point of the cin statement. And what's happening is when I enter the actual value, it's storing it into this integer. So I can put a comment here and say user enters value and it is stored into integer var variable. Now, the other question you're probably asking is, well, what happened to the value here, because you initialized it as 7? When the user enters a value, it's going to overwrite whatever value it was previously. And this, again, this is an assignment statement. So you got to be careful with your variable assignments, and as you start using cin and cout, because then you can overwrite whatever value you initialized it as before. And it always takes the latest value. So at this point, if I do a cout, the value entered is integer var. And just to go back to what I taught you, this insertion operator goes with this. This insertion operator goes with this. And this insertion operator goes with this. So what I'm going to do is I'm going to comment this and say, and I can do it on the next line actually. Do that. And then 2, do that. And then 3, do that. Because again, each insertion operator has to go with its operand. And the operand could be a literal, or it could be a variable, or it could be a manipulator, which in this case is the end out. If I run this, compile and run, I enter a number, and it's going to say the value entered is 5, because that's what I entered. Okay. Okay. You could also prompt the user to enter multiple numbers. So I can do, please enter 3 numbers, and I can separate, again, just like we do with the insertion operator with cout, I can do the same thing with cin. So I can do cin, and I can do I number 1 and I number 2. These two variables are declared in my declaration section over here. I've initialized them to these values, but when I use a cin, they're going to be irrelevant because they're going to be written over. And then I integer var is this variable that's an integer data type, and again we use the typedef to declare it as, to declare our own data type, which is called integer, which its underlying data type is int. And with this particular case, and it's for every space that I write, it's gonna split it so that it knows as to what point to read in the variable. So if you see it, it's a lot more descriptive. Compile and run. Now it's allowing me to enter 3 numbers. So the way I would do this is I would enter 54, then I write a space, okay, then I do 32, and then I do a space, and then I do 76, and then I press enter, and then the value entered is going to give me 54, which is what I entered for the first value. I want to see what the other values are. The values entered, I'll just put this as a plural just to fix my statement, and then I can say I number 1, and then I number 2. And then you have to remember that I also want to put a space in between each number, so I'll just add something like that, right? Take this out. And now, as I execute my program, it's going to ask me, please enter 3 numbers. So I'm going to enter 44, 56, and 98. And then it'll say the values enter are. I should say are 44, 56, 98. As you see, there's a spacing between each number because I put in a space in my cout statement, and I had to put an insertion operator for each space. So here's that for that. Here's that for that space. Okay, and I still had to put another insertion operator for my variable. So this goes with that, and this goes with that. What I suggest you do is take this program and write it yourself, and then match up the insertion operator variables with the insertion operator so you see what's going on. Okay. The white space is basically a delimiter for the cin, so that it knows that if you type in a white space, then it's going to completely ignore it and go into the next value, so you can separate the input values. Not ignore it, it's going to just, it dictates the cin to skip that space and then use the next value so that you can assign it to the next input value. Okay? And that's it for cin. So let me take a little bit of a break and then I'll continue.